Welcome to this explainer. Today, we're embarking on what I like to call an intellectual expedition. We're going to dive deep into the art of research. And I don't mean just, doing a quick internet search to settle a bar bet with a friend. No, I'm talking about pushing right to the absolute edge of human knowledge. We're going to operate with the exact precision and insatiable curiosity of a PhD student. It's really this thrilling journey where we get to lift the veil on super complex topics and figure out what is actually going on beneath the surface.
Think for a second about how we normally consume information these days. It's mostly just endless, mindless scrolling on our phones, right? It's incredibly easy, it's totally passive, it just washes right over us. Sure, you get a quick dopamine hit, but an hour later, you feel completely empty and honestly not a single bit smarter than before. But doing actual, deep research, that is the exact opposite. It's demanding. It takes real focus. But here's the secret. There is something profoundly meditative and incredibly rewarding about structured research. When you swap out that endless feed for a deep dive into something you actually care about, you go from being a passive consumer to an active explorer. You aren't just absorbing anymore, you're discovering.
Okay, let's dive into this. Step 1. The art of inquiry. So every great journey has to start with a destination, right? And in research, that destination is your core question. We've got to take a vague, hazy idea and sharpen it into a laser-focused objective. If you go online and just search mental health, you are literally going to drown in millions of articles. That's not searching, that's just wandering aimlessly. We need to narrow the funnel so we have a precise target. Just look at this progression. We start way up top, super broad, with mental health. Then we narrow it down to a specific angle, like socioeconomic status. And finally, we forge our precise question. What is the impact of low childhood socioeconomic status on later psychiatric development? See the difference? You can instantly feel how that final question demands a highly specific, structured answer. The more precise your question is right out of the gate, the better your whole research process is going to flow.
Moving on to phase 2, the literature hunt.
All right, so with our target locked in, imagine this next phase is venturing out into this wild, untamed landscape of existing knowledge. It can absolutely feel overwhelming at first, but what we're looking for are reliable landmarks. Specifically, we want to hunt down the classic papers in our field. Or honestly, even better, try to find a really comprehensive review paper published in the last 5 to 10 years by authors you can trust. Now here's the trick. Once you find that solid review paper, don't just read the conclusion and call it a day. Go straight down to the very bottom of the document. The reference section of a good review is an absolute goldmine. It's essentially this pre-drawn map of the exact knowledge network you need to navigate. Every single citation there is a main node. It's a signpost pointing you to the most crucial, cutting-edge conversations happening in that field right now.
Now, what's really interesting about this is how we actually use those citations to build our own map. We do it through something called citation tracing. First up, you have backward tracing, which is looking at who your anchor paper cited. This helps you understand the foundational history of the idea. Where did this come from? But equally vital is forward tracing. That means seeing who has cited your anchor paper since it was published. Tools like Google Scholar or ResearchRabbit are absolutely amazing for this. ResearchRabbit actually is kind of like Spotify for academic papers. It visually connects all these citations for you, which helps you stumble onto these absolute bleeding-edge breakthroughs that you probably would have totally missed otherwise. By tracing both backward and forward, your knowledge network becomes beautifully wide, incredibly complete, and you ensure you aren't missing any major developments.
Which brings us to phase 3, cultivating a critical eye. As our knowledge network starts to really expand, we've got to make a huge mindset shift. Think about it. When you're handed a textbook in a university course, you're generally thought to just blindly trust whatever is inside it. But when you're operating out at the frontier of research, you absolutely cannot do that. You have to equip yourself to battle bias, sketchy motives, and just flat-out bad data. You are a detective now. So what kind of warning signs are we actually looking for out in the wild? Well, always check the funding sources. If you're reading a study on a brand new medication and it's funded entirely by big pharma, just keep that context in the back of your mind. Also, pay close attention to the tone. Does the paper sound genuinely objective, or does it kind of feel like they're aggressively pushing an unproven agenda? And most importantly, this is huge, do the headlines actually match the data they're presenting?
And that brings us to one of my absolute favorite examples. You will so often see popular science articles screaming a headline like, "Depression is caused by chocolate." But then, you sit down, you actually read the underlying paper, and you realize the study was only ever conducted on rodents. So the headline really should read, "Depression is caused by chocolate in mice." It's a totally different story. So always ask yourself what the data is actually proving, rather than what the super catchy clickbait title claims to prove just to get your views.
A massive part of reading data correctly is wrapping your head around correlation versus causation. And this is especially crucial in fields like neuroscience. Obviously, we can't just ethically manipulate human brains to see what happens, right? So a whole lot of our research ends up being strictly correlational. Because of that, we have to be incredibly, painstakingly careful to distinguish between two things that just happen to occur at the exact same time and one thing actually causing the other.
And here's a pro tip. As you read through a paper, pay really close attention to the discussion section. You might instinctively think that a study pointing out its own flaws is a bad sign, like they did something wrong. But actually, it's the exact opposite. Good research fundamentally disagrees with itself to a certain degree. When a researcher thoughtfully outlines the limitations of their own study, it's this beautiful sign that they are operating right at the very edge of human knowledge, and they're showing you exactly where the darkness begins.
All right, moving right along to step 4, mapping knowledge networks. So you've hunted down the literature, you've critically evaluated it, and now we need to build our base camp. You've got all these scattered, highly technical ideas floating around, and you have to structure them into a personalized learning curriculum so you can actually make sense of them day by day. The best way to do this is to treat your digital workspace, whether that's Notion, Zotero, whatever you prefer, like a mini lab book. Set up dedicated columns. You want a project page, a place specifically for your notes and summaries, an open questions list, and daily logs of what you've actually accomplished. By treating your learning process like a rigorous lab experiment, you end up creating this incredible goldmine of personal insights that you can easily navigate whenever you need to.
And within that lab book, I literally cannot stress this next point enough. Document everything, but especially your earliest, most basic questions. You have to document the eyes of a novice. Think about it. As you dive deeper into a complex topic over weeks or months, your perspective is inevitably going to change. Those pure, unclouded questions you had on day one, they are incredibly valuable. And unfortunately, they are incredibly easy to forget once you start suffering from the curse of knowledge. So please, write them down.
Finally, we arrive at phase 5, the active creator.
Okay, you have ventured out, you've mapped the territory, you've gathered your insights. Basically, you've reached the summit. But now you have to return and transform all that synthesized knowledge into something entirely new. This right here is the stark dividing line between just knowing about something and truly understanding it. Passive learning, stuff like reading, highlighting, endless scrolling, it just gives you the illusion of competence. But true memory consolidation, that only happens through active learning. You've got to force retrieval. You have to forge an essay, write a script, maybe teach the concept to a friend on a whiteboard, or just draft a blog post. When you take all that scattered knowledge and actually shape it into a coherent answer to your original question, wow, that is when the magic really happens.
Now, to keep this active engine running day after day, try using these 3 momentum builders at the end of every single research session. Just ask yourself, what did I learn today? What is still unclear? And what is my next step? Seriously, just noting down the answers to those 3 questions creates this irresistible pull for the next day. If you write down, read the methodology section of the Smith paper right before you close your laptop, you completely eliminate the friction of starting tomorrow. You won't procrastinate because you already know exactly what to do. It takes a potentially tedious multi-month research project and transforms it into a really thrilling daily pursuit, driven entirely by your own pure curiosity.
I want to leave you with a final, deeply contemplative thought here. We go through this incredibly intense PhD level process to find answers. But the reality is, research is incredibly malleable. What we confidently present as scientific fact today, it might be completely disproven in 10 years as our tools and our understanding evolve. So as we actively create and share our findings in a world that is just so desperate for certainty, how do we embrace the beauty of the scientific process without falsely claiming absolute truth? How do we passionately share our journey of discovery while having the humility to admit that, hey, we might still be wrong? Something to think about as you embark on your very next intellectual expedition.